Hello everyone, thanks for joining. I'm Maitri Sinha Chaudhary, a data and AI tech enthusiast. This is the third video in the series of ML learning series, and apologize for not being able to post videos in the last few weeks. But as I've been swamped with some other responsibilities, so let's start. So this is the data collection and system design. We have actually released another part before this for this particular step. So, if you recall, in our previous series, and I give the links in the description, so you should be able to refer back to those videos in sequence. We discussed about the basic larger blocks in any ML project. What was that? So it was a big picture that we discussed, the strategic steps, what, why, how. Basically, this is the step when you do not code or anything. Basic you immerse yourself into the problem statement, figure out what should be your next step. You can say a strategic step. Next is data collection and system design. This is a crucial step before we proceed because, and this is where the part two that we are discussing it, we'll be discussing today. So this is the step where you figure out what kind of data you require. We can do a little recap of that as well. And this is the step, unless you already have a ready-made information for your further next step on, exploratory data analysis and sampling and all that, you would require this step to be taken very seriously. Either you will work yourself as a data scientist to collect this information, or you will engage with data engineers to ensure this step is well executed in support of your next actual step in the ML project. EDN sampling, we will talk about it later on, so let's not spend time. Data cleanup and transform. I will do a little bit of this discussion within the data collection system design phase itself, but that would require a dedicated session, so I will be very quick to just brush through this topic. Model selection, train, and fine tune. This is the key step which we will discuss. Serve the model and predict. This is why you are doing all of this. This is the step you are doing everything for. Monitor, improve, maintain. This is what will be like, you get married and you have to work towards keeping the marriage successful. So this is that step. Monitor, improve, and maintain. And then finally, how you're serving it, how you're keeping the served application updated and relevant for the prediction that you did all this jazz, all this activity for. So we'll discuss about all of that. So um, data collection and processing blueprint. This is a very important second step in this second block of data collection and system design process. So let's see. First of all, we want to do a quick recap for the step one, which was ideally the um, your first block, the larger block that I discussed, the big picture. We defined the business problem. We defined the data requirements in the last step. What we did in those steps is clearly outline the problem statement, what kind of problem it is, fraud detection, customer churn prediction. So basically, in our case, uh, in the series, the use case that we have taken, housing price prediction, median housing price prediction. So basically, this tells you, before I talk about the target variable, what kind of problem statement it is that tells you what kind of model that you will actually require. Are you predicting a value? Are you categorizing something? That would decide your basic model that you need to go ahead with. You will further shift your decision based on a lot of other factors that I will get into. But what I'm trying to say, in your first step, you immersed yourself with the problem statement, as I just talked about. You identify the target variable as it what you want to predict, which is your y. Uh, y label is your and the key features, which is your nothing but your x. So ideally, if y is your, like in our case, is housing price, I'm gonna predict that's my y. But there are other influencing factors or features which would kind of um, keep a relation or not keep a relation with this target variable. And that's exactly what you will plan on modeling. We determine the high level necessary data sources and also the kind of data format and frequency, as in what kind of data sources I roughly would require. In this case, you have a ready-made file, but in real life projects, you may need to figure out 10 different departments, 10 different databases or data sources. It could be a file, it could be a database, it could be a structured, simple database access, it could be unstructured files, emails, semi-structured information such as JSON file, you name it. And then there could be a different frequencies. It could be real time, near real time, batch, right? So depending on the use case, and we'll go deeper into that in another video. Here also I will kind of take you through, but I will not go very deep into it. Why? Because then I lose the, I would say, the momentum of actual step. So I don't want to spend a lot of time on a step that is pre-step, right? Now, today we will talk about a roughly, very short manner, the data collection strategy that you may need to have. So it's if you look at the situation like in the business, in the first big picture, you decided what to cook, your recipe, right? Um, Next step, you started deciding what would be your ingredients for that recipe. You tried to kind of identify sources, format, frequency, how will you source your ingredients, things like that. The data collection strategy, it's about what kind of data source. I mean, I know in the last step you defined the data sources, but is it a database? Like, are you taking order data from some ERP system or invoicing information? Or is it like, a file coming from some legacy organization? They place some file in some server. You never know. Is it an external API or open data set, which we are using in this particular case? Is it some websites where you need to scrape some information, of course, with permission? IoT devices, is it a use case of certain sensor information being collected in a form of JSON? You never know, right? So this is the second level of deep dive, as in your double click on the last step, where you're figuring out what kind of data source you would actually require. Is it a handcrafted user generated data? Um, or even if it's not handcrafted, let's say in some cases you some of the you know devices would interact with the user's smartphone and collect information for more customized ad ad and promotions and campaigns. So that's also a user generated data. Sometimes we don't, a lot of companies don't do a proper ethical practice of collecting information, so they would just capture the data, but ideally they should seek permission from you. And we'll discuss those, we'll run through. In this series, I don't want to go into a very much of a deep dive because then we lose the momentum, as I said, the actual step. Next is the data collection approach. Now, based on the kind of data sources and the use cases, you would have to figure out data collection approach. Now, let's take an example. Is it batch? Is it real-time streaming? Is it manual data entry? And is it event-driven? So let's talk about quick run through these. Now, batch extraction is, let's say, you're a CEO and you require this quarter's financial performance. You really wouldn't require real-time data hitting your reporting system and taking a real-time decision because it is a strategic decision. Data integrity is more important than data, fast data. You don't need that. So as a CEO or as a strategic role in your organization, you would require a data to be on time available, well maintaining well versed integrity with the rest of the systems, and it is telling you revenue recognition. Let's give you an example. So you really don't need a real-time streaming of that information. It could be a batch, it could be a monthly file, monthly load, or it could be a monthly ETL, or it could be a daily ETL, which feeds to a reporting system that the C-level executives would pay attention to, right? So those are the cases where batch extraction happens, where it's not real-time streaming. Could be a real-time streaming. Let's say you want to target a real-time audience um, in a auditorium or a stadium, and you want to capture real-time customer feedback on a specific product or ad being shown. Right, so that's a real-time streaming, right? And that's where we probably will have different video will discuss about the real-time streaming use cases and the tech stack for that, discuss all of that. Manual data entry and surveys, HITL. HITL is a newly introduced, I wouldn't say newly introduced, actually it's very much introduced. It's being used since a long time, is where you cannot just depend on the data that you see. You need a human with judgment being part of the decision. Let's take an example. You're performing a live, you're performing an operation. Yes, a robot can perform operation without supervision, fantastic. But there are situations where the generated data is vetted or validated by a non-robotic or person with expertise going through that, so that they can ensure that a wrong trigger has not been fed into the training information for that particular machine learning system. So human in the loop, HITL, is a practice, you can say, that's being applied. So based on that, and also event driven architecture. Event driven architecture is, by roughly in one liner, I can say whenever somebody enters through a gate, that person's photograph and fingerprints collected, or maybe heat signature sent to certain device, right? So it's not like all the time it is doing anything. It's anytime somebody passes through that door, that device that is installed as a sensor is collecting some information from that certain event of somebody passing. So that's an event-driven architecture. And again, I can come up with a different video primarily focused towards that. So based on these specific approach through which you can collect the information, your ETL processing, your ETL strategy, or your whole extract, transformation, and load process itself will change. Now, this is a data storage solution. So far you've decided what kind of sources are, what format, frequency, right? How will you be able to collect the information? Now the question is, how are you going to store that information? So if I talk about raw data, let's take an example. You just need some sensor information, which you don't need to use, or let's say user profile information, which you don't need to use right away, but you can store it into the file system, similar to our big data, where you like in HDFS, you store the file and then you later on either build a table on top of it, or you use it for any other purpose directly from the file. So you can decide based on that. But raw data, as it is coming, where to keep, you can keep any file system without having to run any ETL process right away. And then it could be, if you're using, depending on what kind of cloud system you're using, could be AWS S3 or Azure Blob, Microsoft, or Google Cloud Storage, GCS. Could be a structured or unstructured information, what kind of information that you're dealing with. And again, I'll come up with a structured and unstructured based, the approach to store, process, and load information. I will come up with a separate elaborate video on that. But depending on what kind of data that you're dealing with, could be structured only, could be unstructured only, it could be a combination of both, it could be a combination of semi-structured as well, like JSON file, or text file. So SQL or no, a combination of SQL or NoSQL databases. SQL which primarily which only deals with structured information, where a relational relation can be established between the different dimensions within the data ecosystem, and NoSQL database, which are also required for certain use cases. I'm not getting into detail into this video, but I will come up with a separate video on that. And of course, if you need to have a repeatable process, as in you need report to be updated on a daily basis, so you want to have a system in place. It could be a simple data warehouse, it could be a simple data lake, it could be a combination of data lake house, which is um, it could be a Databricks in any of the three clouds, or Snowflake. So basically, depending on um, Snowflake is a data warehouse, I would say, not data lake house, in my opinion. But again, there could be different opinions about it. But where a repeatable orchestration of the information is needed, you would require a big data processing system in place. It could be multiple different tech stacks, but ideally, these are the categories of storing situations where you need to plan ahead. Now, this is the step where you actually do the ingestion, right? This is where you will actually put up the pipelines, right? You would ingest, you may use tools like Keplo, NiFi, custom ETL scripts. There are legacy scripts, Informatica have an issue. Depending on your data use case, you can use these tools. And then I would not discuss the cleanup step, the data cleaning and pre-processing from the ML context. There are DQ steps within the ETL that can be part of this data ingestion, cleaning, and pre-processing. But and this also deals with fix inconsistencies, handle missing values, remove duplicates. These are the steps within ETL itself that can be a one layer, like DQ layer as we call it, can be there. But imputation, removal, standardization, normalization, these are steps of cleaning in an ML context. And I would stop this video here, because I would like to come up with another video where I would explain in detail about these data cleaning and pre-processing step in ML context. So stay tuned to the videos which are upcoming, and also refer to the videos which have already been posted in sequence if you can. All right. Thank you, everyone. I think we will connect into the next video. Thanks for watching.